Okay, so we went over last Wednesday went over a few language constructs, which including like a function template, function pointer, as well as some of the standard library, such as a vector and map. But we're talking very briefly. It's like almost a little bit here, a little bit there. And the things I like to pursue at this point is now we're going to see the real example of each of this idea and also in the context of your homework that you're working on that. So I'm actually going back to the program. Oh, it's here. That when we actually talk about this sample program that I released in October 24 about JSON RPC. How do we actually be able to have a client server concept? They can work together. By the way, on Wednesday, I'm going to bring this box. I will expect you to install JSON RPC, and then you can actually start to communicate with your program. That's why I gave you the account that we can all share. And the thing is that when you actually did the experiment with this box using JSON RPC, then I will have a record about your student ID number or something for counting your participation. I'll give you more detail. But this Wednesday, the purpose is not really for that stage yet. This Wednesday, what I like to do is that all of you come here. I want to make sure that using the class time as well as discussion time to actually help you to install JSON RPC. So if you haven't installed JSON RPC, you really don't know what to start, don't worry. This Wednesday is going to be like a party for us to help you to actually get for you to help each other, okay, to get, this is what I call RPC installation party. But my purpose is that by this Wednesday, I want to make sure that everybody has a reliable environment to run remote procedure call for JSON RPC. So then we can actually deal with the fun using JSON RPC. Okay, so some of you already be able to run this program. Some of you still, because if you didn't install that, you obviously cannot get this program run. So hopefully this Wednesday, after this Wednesday, everybody will be able to enjoy the fun about programming in a distributed way. But I want to actually, particularly, I want to start with this program to motivate some of the feature I would like to introduce today. So one of the key file is HW5 server.cpp. So in this file, if you remember, how do I be able to handle the call? So this is a call called dump to JSON. Dump to JSON basically receive a few parameters from the remote. And this part is a little bit ugly, but take a look at what I did. I basically, first thing, when I receive the call, I will check whether the class ID is what I'm expecting. The class ID is a thing, and the object ID is a 00001. If both of them are actually match what I'm expecting, then what I did here, you can see here, what I did here is that then I know the thing pointer is the pointer I'm expecting. Okay, so essentially, all the program I was writing over there is just for one pointer and one object. That object is a thing, is basically Swedish meatball, as we will look. And then I did something very, I would say very, very unprofessional. It's called global variable, okay? So by the way, if you write program, you use too many global variable, you are just like me, we're shooting our own foot, okay? So we try to avoid global variable. So you see that I have a global variable here. I declare as a thing.ptr. And how did I set it? Let me show you how did I set it. In the bottom of the program, in the main program, when I create all this object, particularly I create all the Swedish meatball. And then you can see here, I hardwire the pointer, the reference of the Swedish meatball, and then to this thing pointer, the address. Okay, there are a few bad things. Okay, I just show you as an example. Number one, I use global variable. Number two, the program is only designed for one particular object. And you can think about, I write a huge server while Facebook is handling 2 billion active users. We're handling just one thing out of one user. That's actually, that scale doesn't look good, right? And the third thing, which is I actually did wrong here, is that this, by the time this memory is gone, for example, I have an object or thing called Swedish meatball, and I just killed it, Control C, I killed the process, guess what? The object is gone. The object is gone. And I have to restart the server, I have to restart everything again. I mean, if you think about that, this example show you how the client can talk to the server, but there's a few things, at least 3 things that are wrong, and which I want to actually address today. So let me repeat. Number one, I don't like global variable. Number two, I need to have a better way about search the target I'm looking for. And the third thing is that I want to actually maintain some kind of persistency such that the object will be able to still survive even I actually kill it. Yeah.
Is the and next to the Swedish meatball represent the object itself or the address?
Address. If I put an and before any variable, that means is the address of that variable. Yeah. I mean, that Swedish meatball could be anything. So that's and. Yeah. So this is, if you put an and at the end of the type, that means it's a reference. But if you put an and sign before any variable, that means the address of that variable. Okay. All right. So let's actually see how I fix it. So the reason I want to introduce this, now we're going to the November 7 folder. The first thing I want to introduce you is the standard template or library. Actually, it should be C++ standard template. There are many templates that we can use. Let me actually bring the slide back. Put my now this one. Where's my stuff? Class template? I thought I have that. Last 10, I lost that. Ooh, that's not good. Okay, I'll just try my luck to see if it's 15 or 14. The old one. No, not this one. No, not this one. Not this one. Oh, I'm actually getting myself. Here. Okay, this is the variety of C++ standard template. For example, you can have a template called list. That's a data structure. You have a template called vector. This is essentially the equivalent to array. And then you have DQ, you have a map, you have a set, you have a multi-map, you have multi-set. So this diagram, and then you have a stack, you have a queue, you have a priority queue. So this diagram, this flow chart is helping us to decide which standard template that we should actually use for our need. And the thing is that I think today I'm going to pick a particular one, which is associate container instead of sequence container. I think you guys are more familiar with sequence container, which is essentially vector or queue, which is like array. You have you have older about things that are coming up. But what do I mean by associate container? Associate container means that there's not necessarily any kind of given sequence, but any element within this container that has a key. It's essentially like a JSON. It's a key value pair. So you can think about you don't have just an object that you worry about, but you have a key that's associated with that object. So that's called map. So we're going to actually look at how I'm going to use map to actually enhance the program of HW5 server.cpp, which you can actually take a look at the code under GitHub. So let's actually take a look at HW5 server.cpp, the newer version under the November 7. Okay, over here, the first part of the code is actually the same, except over here, now I remove that global variable, but instead I create a map. I create a map, and this is how I declare the map using the map template to declare a map. So I call that map thing map. And in the thing map, the syntax is that I have to say std : map. I mean, in fact, I'm kind of duplicate because I already used the namespace std. So basically, I have to say map. And just like every template, the simplest way of using map is actually have a two data type I have to provide. The first data type represents the data type of the key. And the second data type represents the value because it's about key value pair. In this case, I actually select the key as the element is actually a string. You can think about the keyword. The keyword is a string. While the value of the map, each of the element, is actually a pointer of thing. I mean, I could probably use thing instead of star, but using thing star, the advantage is that I potentially save memory when I have a multiple of this. Okay, so this is the name of the standard template. This is the configuration of the template. Remember, whenever we do template, they usually allow us to provide extra information to actually configure that particular template to fit our need. In this case, we actually take the key to be string, and the value is actually a pointer. And then, of course, the whole thing up to this point, std : map, and then this between these two greater than and smaller than, and then there is a variable. So the variable is called thing map. Okay, that's how I declare a map. And now we're going to see how we can use this map. So now let's actually go to the main program, how I actually be able to use that instead of hardwire into the thing pointer. This is the way, it's still exactly the same code. I mean, you can actually compare the code between November 7 and October 24, and you will see the key difference about how to use map. So I'm still creating a Swedish meatball. I have to skip this part. I will actually get to that because the part I have over there is related to how do I actually store the Swedish meatball to a file. I will talk about that later today. But this line is how I'm going to use the map. The first part, you can see that what I did is it's almost like an array or almost like a JSON. What I did is thing map, and then I put a bracket, inside bracket over here, that's the key. The map has a key. So basically I'm using the object ID as the key to store the Swedish meatball. So basically Swedish meatball, I put an M sign, that means it's a pointer. So the pointer basically save it under the map. So that's how I save the map. Okay, by the way, the next two lines is a bit tricky but just put here as an example that this is the typical line that you can do with a map for you to print every single element in the map. It's just like an array, right? Array, you actually can go over this, but I mean, what do you mean by map? You want to do an iteration about printing every element. You use this two pieces of code using the for loop. This is a for loop, but it's actually designed for the map. You can see that it doesn't have like an index, but it's using the key value pair to actually do that. You can actually go over the thing map and then print everything. Okay, so this line. The things I want you to understand that this line is how you're going to put one element into the thing map or any map with the key specified between that bracket. Okay, that's the how you can use the thing map. So now let's actually, yes, in the back. Yeah, you can use anything as a key. It doesn't have to be string. You can use object, you can use anything. Yeah. So map is actually quite powerful because you can actually do everything. But a lot of practical case, string is the most popular one, I would say. Yeah. All right. Yeah.
Could you just clarify as to what the for loop condition is saying?
The for loop is essentially, this is the thing that is actually go through all the key and the value. When you do this bracket, you basically say key and value is the variable I want to print. And this is because when you do this auto with a for loop, that it will, every time it will retrieve a pair of key value from the map one by one until it's done. And then because you have that key and value defined there, then you can actually print the key here is a variable. It's actually referred to that key and value over there. And then it will print the key and print the value. I'm going to show you how it works. Okay, thank you. All right, so this is a way to save it. So now we're going to retrieve it, right? So let's actually go back to the other piece of code. Let's see how this works. So now I'm doing dump to JSON. Instead of trying to hard code it, try to compare both the class ID and object ID. But by the way, this is an improvement, but not ideal. So I still have to check whether it's a class ID is a thing. So you can see that now I didn't actually check for the object ID. I only checked the class ID because this particular one, I want to handle only thing. Okay, so the first thing I actually check whether the class ID is a thing or not. Okay, if the class ID is a thing, then I'm actually going to check the thing map. You can imagine if you want to do both thing and the person, then you probably need two maps. One is called person map, one is called thing map. And then that's why you have to write your code according to the map that you set up. But let's actually take a look at this piece of code. This piece of code is essentially for us to retrieve the relevant element from the map. How do I do that? The first function, this is just an example. There are multiple ways to do that, but this is one of the very popular way to do that. Is first I call this function called find. So under theme map, there is a one function called find. And find take one element, and that element is going to be a key value, a key, not value, key, a key. So the key is object ID. Where is object ID? The object ID I actually obtained from the input parameter, which is a string, happen to be the type of the type of the key for this particular instantiation of template. So that's why this is actually a good parameter. When you have a find, then this one, the template already decide the thing map, the key value, the key is actually object ID. So you basically put the object ID here. So the thing is that the find function is basically referred to iterator. It's sometimes like a particular index of a particular element that's within the map. So the thing is that if there is a one element that's actually match that object ID, then it's going to return the iterator that corresponding to that element. Well, if it doesn't have this element, because sometimes you give me object ID, this object ID doesn't exist, therefore it will need to return something, and the value it will return is going to be called thingmap.end. So thingmap.end will return the iterator, which is basically one after the last element. Think about the array, it's basically the extra element. So we usually use that to indicate this is actually the way to decide whether this element is actually in the map or not. This key is in the map or not. Okay, once you actually decide that this is not equal, this means that, okay, this element is actually indeed in the map. So we're good, we're good to go. So you can see now I have the thing pointer. By the way, now the thing pointer is no longer a global variable. It's actually here. You see, now I actually change it to the local variable. It's a pure local variable, doesn't matter. You can call it, you can do whatever you want over there. That's very simple. So I essentially retrieve the value of the pair. You see that now I'm using thing map object ID because I know that object ID is actually there after I do the thing map.find. So now I can actually directly call it using the array notation with the object ID that it will retrieve the value that correspond to that key object ID. And now I actually have the thing pointer being set to that particular object that I deposited earlier. So up to this point, we actually got our object pointer there. And then since I have the object pointer, now I can actually call thing pointer to dump to JSON. This piece of code, by the way, the rest of the code is actually equivalent to what you have seen in October 24 version. And then you put into the result, and then you say result status successful, then you can return the result. Okay, so that's this part of the operation that you can actually be able to use the map to actually managing a lot of a set of objects that's under a particular class type. Okay, so there's a few things I want to make a comment, but before I did that, any question about the basic usage of STD map, this template? Okay, good. All right. I would say map is probably the more complicated the STD template. Okay, the other template should be even simpler than this one, because map is usually it's based on association. Okay, so I'd like to make a few comments over here. So we talk about the concept of inheritance. For example, thing, you could have IoT thing, you could have a shadow thing. And we talk about virtual function. So one of the idea is that in object-oriented programming, especially with C++, is about casting. So essentially, the map is kind of useful, is that I can actually store multiple types of objects as long as they are all under the inheritance hierarchy of the thing. So essentially, I can create this thing map, and I can actually use this thing map to store both thing and IoT thing and shadow things together. So from the map perspective, is all thing or being casted into a thing. And then essentially, in the map, I cannot actually tell whether this is a thing or is an IoT thing, is a shallow thing. I don't know because it has been casted over here. So, but the thing is, when you actually make this call, this actually only guarantee that the return of the value is a pointer to one of the subtype from the class thing. But whether is whatever type it is, you really don't know. So the thing is that when you actually call this function dump to JSON, then it will invoke the correct one. Why? Because virtual function, it will actually realize that how this object was initially created. Because it's created, then I can actually be able to save that. So which means that this actually triggered another problem is that when I create this map, okay, think about this is actually a little bit tricky. When I create this map, you see that I'm actually I'm storing the pointer, right? I'm storing the pointer. But I can also store the value. The trouble is, if I store the value, I lost my virtual function. Because when I cast it to thing, the value only keep the thing part. And then I lost the IoT part, or I lost the shadow part because of that. So alternatively, you can actually put this into thing n, which is you actually store the value as a reference. If you actually store the reference, then the virtual function is still home. Okay, so this is small, but very important when you actually deal with data structure with virtual function, because virtual function is something you're supposed to only create this object once. Whenever you make a copy to a casting type, then essentially when you do that, then your virtual function is gone. Okay, so that's why it's important for C++ programmer to actually realize when you use this data structure, when you're dealing with virtual function, when you do casting, those concepts, it's confusing, but you need to consider all this in order to get it done correctly. Okay. All right, so that is the map. Okay, that I actually took care of two problems already. I don't have a global variable, good. And I don't have like a one hard-coded object for the whole logic. At least now I actually can serve all the objects within the same type using the standard template called map. But still, this object, when it's gone, is gone. This object, whenever I turn off this machine and the object or the final result of the computation is gone. I have to restart over again. Obviously, in real application, that's not acceptable. Real application, we always have to save what it does, and then we will be able to do that. And in fact, to have that capability, we have to do something similar to what you were asked to do for your homework assignment number 3, which is JSON to object. So homework 2 is dump to JSON. You actually convert a C++ object to a JSON format. So homework 3 is actually try to handle this situation is that I want to actually save this object somewhere and I can actually retrieve it. So let's see how this can be done. I'm actually also show you part of it because if I show you the whole thing, I'm basically helping you to solve homework 3 already. Okay, so I'm actually going to clean up my data structure a little bit. You can see that I have a directory called JSON object. I'm going to remove all of them. So this now the directory is empty. Okay, I don't have anything that's actually stored persistently. I have a subdirectory called JSON object currently is empty. All right, so I'm going to look at the code for server. Now the server code looks a little bit different from this part. So I said I skip this part. I'm going to show you this part, how it can be done. So this is just declare some variable, the return code integer. I want to see if the code is okay. And then I provide a name buff, which is allow me to specify the name of the object, because I actually try to save this object to a file. So one object to one file. So I have to define the name so I can actually save it and retrieve it. Look at how I define the name. The way I define the name is namebuff is ./JSON object /%s, which is the one parameter, the second parameter .json, which is a thing 0000001. So basically you use the class ID and object ID for the name of that particular object, but it's no longer JSON object, no longer C++ object, it's going to be JSON object. So let's see the only a few lines, you can just call the facility that we provide for homework assignment number 3. So the first program I did is I create a JSON value, and this is the JSON, the Swedish meatball dump to JSON, right? This is the function you implemented or you will implement it for homework assignment number 2, which is basically print the thing. By the way, all this program is actually I already provided to you as a sample code. So Swedish meatball dump to JSON is essentially convert the Swedish meatball into a JSON string. And I save that JSON string in the JV. And then this is what I did. I did a my JSON to file. My JSON to file is a facility I gave you inside ecs36b _ JSON.cpp. And that program basically, the first is the name of the file I tried to save. And then I'm saying the pointer of that JSON value, this 2, and then it will basically get back the RC saying that whether there is any error, if there's no error, then that's good. You actually have that. So this few lines of code in the 1107 is going to help you to save your object to JSON. So let me actually try to run the program very quickly. In this case, I don't even need to run. I don't even need to run the client. I just need to run the server. So you can see that I'm actually running the server. You see that there's a few things I print. I actually print the object thing _ 00001.json, and this is actually the piece of code that's actually the map print that every element, because I only have one element, this is the key, and this is the value, which is pointer. Okay, so now let's actually take a look. If you go to this directory, previously this directory has nothing. Now if I go to this object, now you can see, now I have an object of this file with 665 bytes. And let's take a look at this file. What is this file? It's a thing.001. It's actually the JSON. That's actually the result from the dump to JSON. So essentially, what we did is nothing magical, but just take the result of dump to JSON and save it as it is, as a JSON format. I'm just using that function to save as a file. And why I want to save this file? If I save the file next time, if I run the program, I can just reload this, because this represents the latest information about that JSON or about that motorcycle, about that person. And essentially, your homework 3 is how do you actually convert this back to C++? I can continue my computation. Okay, so of course, if I want to bring back the thing from JSON to C++, then that's actually what I asked you to do for homework assignment number 3. But instead, I'm actually doing something simpler. Let me show you what I did here. Okay, so what I did here, if you look at the code, I have something called GPS stuff. So what I did, let me actually just define GPS stuff. So this will be included. Okay, so what's this part? This part of the code is actually very similar to what we have earlier, but instead of save to a thing, I'm actually save a GPS because I actually gave you the JSON2 object code for GPS. So take a look at this. Now I actually create a name. The class is actually GPS. And the object ID is actually whatever the GPS ID I assign. And what I did here, instead of doing thing or Swedish meatball dot dump to JSON, I'm actually doing GPS IKEA Sacramento dot dump to JSON. So essentially, I'm dumping a GPS object in C++ into a JSON format. I call it GPS underscore JV, which is a JSON format. And again, I'm actually doing my JSON2 file to that netbub and that JSON, and then I will be able to actually get it run. So let's actually see what's happening here. If I just make it, and then I'll actually run it again. Okay, so right now you see that I actually have a new object I just create. I create two objects now in my directory JSON objects. The first one I created earlier is called thing, but the second one is GPS. Let's take a look at the GPS. You can see that this is essentially the dump to JSON from the GPS class. It's just the latitude and longitude. Okay. All right. So now I'm going to show you. I'm going to convert this back to the C++ object. How should I do that? Then we can actually call it a break. Sorry about that. It's a little bit delayed. So up to this point, my JSON2 file, I actually, when I call this line, if its RC is a 0, means successful, it will write the JSON to the file. But now I want to actually bring it back. To bring it back, I'm using another function. So I actually create JSON value called GPS JV2. That's the JSON I want to get it back. How do I get it back? I use another function, which is also under ecs36b JSON.cpp called my file to JSON. I'm actually giving the name. This name should be exactly the name I wrote it to the system and with a pointer or reference to this new JSON object. So when I call my file to JSON, if this is successful, essentially I'm actually having a JSON string represent exactly the file. So I'm actually only bring the JSON back. I haven't actually converted to C++. So now this is the magic in this line. So see here, I create a GPS DD. I create a GPS object. It's a blank object. And this is the magic one. The next line, I do new one. New one is the one I just create. I set JSON to object. And with this, GPS underscore JV2, which I got it from here, my file to JSON. So the JSON being put here as a parameter. And then I just say new one, JSON to object. And then with the new one, I will actually dump to JSON again. So you see that this is a two-way street. Dump to JSON, go to the JSON world. And then JSON to object, go back to C++. If you go back 1 million times, the value should be exactly identical. If they are not identical, the programming has some logic error. So that's why I actually dump it again and then print to style string. I should get the result. So let's actually try to see what's happening. You can see that I'm actually save it over there. I dump it and then come back. When I dump it, this is exactly the value, but it's actually in the C++ format. So this is a very simple example to actually show you a few things. So let me summarize a few things we covered today. Number one, we cover map. STD map is something which I think is very critical. for you to learn, because this is one of the very useful standard template. You should know that. And the second thing is that, well, how do you actually use map to design, to organize an object and such that you will be able to manage using the key value pair? And how do you actually be able to retrieve the key using the map interface? And the third one, which is I would like to come to you, is that we start to look at the things called persistency about the object-oriented programming. So previously, object-oriented programming is started when you call the function main. When you type /a.out, it started. But when you hit Control C or exit, every single bit's information is gone. But you can see that I show you relatively few lines of code. You can actually start to store your object in a place that's whatever the storage you want to keep. And then you can actually, sometimes your program has bugged. Sometimes the power is gone. As long as you actually save the object over there, the next time when you come back to your program, you just execute the program, it will reload all the information over here, and you can continue your computation. You can imagine how useful this could be in the unreliability of today's network and computing environment. Okay, all right, I'm going to stop here. Any question? All right, so I will stay here and let me turn off my recording first.